everyone, it's Miss OD here. So day 2, we're going to look at the zero index law and the negative indices. Let's start with the zero. So we already know about when we divide exponents, we just subtract the powers. So for example, if I have x to the power of m divided by x to the power of m minus m is 0 obviously, so my answer is x to the power of 0. However, I also know that I could write this question as a fraction. So I could write it as x to the power of m over x to the power of m. And we know already that anything over itself is equal to 1. So if I have 2 over 2, I know that's 1. If I have x over x, I know that's 1. So x to the m over x to the m is also 1. But what this means then is we have the same question, but we get different answers. So here, this question is the same as this question, but we get two different answers. We get x to the 0 and we get 1. This has to mean that these two things are the same. So therefore, we can say x to the power of 0 must always be 1. So this, we can replace the x with another letter, we can replace it with a number. It doesn't matter what the base is. If you have something to the power of 0, you always get 1 as your answer. So that's the first rule for today. The next one is looking at negative indices. So let's use what we already know as well. Here we know when we divide, we subtract the powers. Remember, the bases have to be the same. So we just do 2 minus 3 is minus 1. No problem there. But if we also use this idea that I can write this question as a fraction, what I can do is I can do some cancelling like we would normally with numerical fractions. So I can say x over x is 1. So it's actually 1 over 1. Let me just maybe get a better pen. And then I could do it again. So I could say x over x, x divided by x is 1, x divided by x is 1. What I have left on top is 1 times 1, of course, is 1. And then here I've got 1 times x, which of course is just 1x. Okay, so same question, but my answer looks slightly different. Let's try it again. I have x squared divided by x to the 4. So I use my division rule. I subtract the powers. 2 minus 4 is minus 2. But if I write it as a fraction, that means I have x times x in the numerator all over x times x times x times x in the denominator. Now if I do some cancelling, so x over x is 1 over 1. X over x is 1 over 1. So what I have left in the numerator, I have 1 over, but in the denominator I still have x times x. So I know that that's x squared. Again, same question, answer just looks slightly different. Last one. Here, remember when it's an x without a power actually written, it's 1. So that's the same as subtracting our powers because we're dividing the exponents. 1 minus 3 is minus 2. Writing it as a fraction and out the long way, I have x all over x times x times x. And again, using the cancelling method, x over x we know is the same as 1 over 1. So what I have left is 1 in the numerator, but I have x times x, which is x squared in the denominator. So what we're looking at here is something to generalize. So what we want is if we notice some sort of pattern. Here I have a negative power, and then remember that's to the power of 1, and I always have 1 over x to that power. Here, excuse me, I have to x to the minus 2, but when I write it the question this way, I get x squared. Same thing here, x to the minus 2, but here I get x squared. So what we can do is generalize this rule and say, well, if I have any number to a negative power, I can rewrite that so it has a positive power, and I just put it over 1. Notice all of my answers are over 1. And then I just make the negative disappear. I mean, it's not really disappearing because we can see we're actually legitimately solving the same question. We just get our answer looking slightly different. But this is then the negative indice rule. Okay, let's put this into practice then. Let's try. Okie dokie. So, the first thing we need to do is simplify, giving answers as rational numbers. Here then, I just use the rule. I have a negative power. It doesn't matter that this is a number. This is the base. The base stays the same always. And to make this so I have a positive power, I always put it over 1. And then I just rewrite that question without the negative in the power. Of course, I can just write that as 1/2. Similarly here, to get rid of it so I don't have a negative power, I always just put it over 1. The base doesn't change, and I now just make the exponent positive. If you can simplify this easily, then I would suggest you do. So we know 6 squared is 36, so it becomes 1/36. Okay. So in both those cases, we used this rule here. Okay. All right, let's try another one. So here we have 3 to the minus 3. I want to make it, because you're not using a calculator with this. Of course, you could just put this into the calculator and get the same answer. But then you probably don't always get an exact answer, because this would be a big long decimal. This is not going to be a nice number like here. Okay, you get 0.5. So we make this a positive power. Put it over 1 first. Write the base the same and just make the exponent positive. That we can do in our head. It's 1/3 cubed, remember, means 3 times 3 times 3. So that's 27. Done. All right, with this question, be careful, only the x is to the power of 0. So remember, this is the same as 4 times x to the power of 0. So only this part is equal to 1. Here we're using the 0 rule. This one here. Okay, but only the x is to the power of 0, so the numerical part stays there. So then we have 4 times, this is 1, and of course 4 times 1 is just 4. Let's look at an alternative question here. So again, be careful. Only the x is to the power of 0. Remember, that's the same as 5 times x to the power of 0. Anything to the power of 0 is 1, so we would have 5 times 1 minus. Now, this is where it changes. 5x is in brackets, so the whole thing is to the power of 0. Remember, we could use our distributive rule and say, well, that's the same as 5 to the 0 times x to the 0, which we don't have to, but it helps give you a visual. So the whole thing is to the power of 0. Anything to the power of 0 is 1. Simplifying that, 5 times 1 is, of course, 5, minus 1 is 4. Combining the two rules here, 4 to the power of 0. So it doesn't matter if it's a letter or a number to the power of 0, always 1. So 4 to the power of 0 is 1 minus. We want to work out this. This is a bit hard to do in our head if we don't have a calculator, but becomes a lot easier if we change it to a positive power. So we put it 1 over, the base stays the same, the power becomes positive, which of course is just 1/4. So then we have 1 minus 1/4 is just 3/4. And that's it. So that's practicing those. They're more straightforward. Let's look at some trickier ones now. Okay, in this case, everything in the bracket is to the -1. So we can just follow the same rule. We're using our negative rule. So it's this one here. And so all we do is we put it over 1 and make the power positive. So we put it all over. 5x. Now if you want to keep it in brackets, you can. But of course we don't need to. It's to the power of 1, so we don't need to do anything. So it's just 1 over 5x. The whole thing is over. In this case, though, it's different. Only the x is to the negative 1. So remember, this is the same as 5 times x to the minus 1. So the 5 does not move. It stays there for the moment. X to the minus 1, using our rule, we just put it over 1, put the base the same, and of course the power becomes positive. Now we can simplify this. Remember, that's over 1, so multiplying fractions, 5 times 1 is 5, 1 times x is x. So we can rewrite that as 5 over x. So notice the difference between these two questions. Be careful. If there are brackets, it makes a big difference. So here we have brackets again. So we need to take care. That means that the whole thing will go over 1. So the first thing you should do is not have the negative power there. It's always easier to do calculations with a positive power. So we have 1 over. This time it's important to keep the brackets for the moment. So 3a, oops, sorry, I missed that squared. So 3a squared, and then to the power of 2, because the power just becomes positive. And now you need to take this one step further. The 1 on the top stays there. And we need to square everything. So remember, when you're using this rule, we're using the distributive rule, this one here. And this time you need to remember that you have to square everything. So we need to square the 3 to give us 9. And we have a squared squared. Remember, power inside, power outside. Multiply those exponents, so we get a to the 4. Okay, the next one is a little bit trickier. I'm going to do this one the long way first of all, and then we can discover a shortcut. So normally we would put it as 1 over whatever is in the bracket, even if it's a fraction, squared. Just using our negative power rule. Now this is the same as saying 1 divided by, when we divide by fractions, we have to turn the second fraction upside down. We take the reciprocal, still squared. Then we would have, let's start again. So here we would have, maybe we'll take the squared first. So we'd have 1 over, and remember, you're going to square both of them. We're using this distributive rule, this one here, where you can square the numerator and the denominator separately. So square the 3, we get 9. Square the 4, we get 16. Now, we need to remember, when we divide fractions, the first fraction stays the same. In this case, it's 1. The second fraction, we take the reciprocal of, or we flip it upside down. So that becomes 16 on 9. And instead of writing it as a division, we change it to a times. So of course, 1 times 16 on 9 is just 16 on 9. Now what actually happens here is, maybe you can already see that there's a quick way to do this. I've cut the rule off slightly, but you've got it on your page. Here what happens is we can just flip that fraction upside down straight away. Okay, 3 over 4 squared is the same as, 1 over 3 over 4 squared is the same as just 4 over 3 squared. So what we can do is we can flip this fraction upside down. In the rule we've got a over b. This is only when it's to a negative power. Flip the fraction, take the reciprocal, and you make the power positive. Let's try that the quick way without going through all of this. So the rule says, if it's a fraction to a negative power, flip your fraction upside down. So instead of 5 over 3, it becomes 3 over 5. And then it becomes to the power of 2. It's because it's 1 over, and 1 is the reciprocal. And then we just square each of them. Square the numerator, square the denominator. 3 squared is 9, 5 squared is 25. Done. If you did it the long way, like in the previous question, you'd get the same answer. Let's try one more. These ones are a little bit harder. So here we have a fraction to a negative power. So the easiest way to do this is take the reciprocal of your fraction or flip it upside down. So it becomes, instead of 2a over b, b over 2a. And we make our power positive. Now, just cube each of the things inside the bracket. Now be careful to cube everything. So you cube the numerator, so we get b cubed. Now in the denominator you need to cube that, but remember you must cube both parts. 2 cubed is 8, a cubed is a cubed. So you're finished. Alright, hopefully you feel confident enough to have a go by yourself at these types of questions now. Good luck!